Statement of Hess's law and its application. Problems based on Hess's law. Hess's law can be stated as follows. The enthalpy change in a chemical reaction is the same whether the reaction takes place in one step or in several steps. If it takes place in several steps, the enthalpy of the reaction is algebraic sum of the enthalpies of the reactions corresponding to all the steps. For example, if a reactant A is converted into the product B by one step and the delta H you determine and getting a value, and the same reaction A to B can be conducted in three steps. For example, in first step A is getting converted into C with a certain delta H, and the C is second step, C is getting converted into D with a certain delta H, and third step D is getting converted into B with a certain delta H. Therefore, the delta H in the first step, this delta H will be equal to the sum of the delta H. If the first step it is delta H1 and the second one delta H2 and third one delta H3, delta H is equal to delta H1 plus delta H2 plus delta H3. The same thing is going to be explained here. Suppose a chemical reaction involves the conversion of a reactant A into some other product B, and the reaction can be carried out by two paths. That means two different ways. Path 1, A is directly getting converted into B and the delta H of that reaction is equal to minus Q. Path 2, that means another method. First step, A is getting converted into C. The delta H1, that is the first step, is minus Q1. That means small letter Q1. The second step, this C is getting converted into D. That means delta H2 is equal to minus Q2. Third step, this D is getting converted into B. That means delta H3 is equal to minus Q3. These are the enthalpy changes of the three different steps, and according to Hess's law, delta H is equal to delta H1 plus delta H2 plus delta H3. If you calculate that, both will be equal to same. That or minus Q is equal to minus Q1 plus minus Q2 plus minus Q3. When the two sides, right hand side and left hand side, becomes equal, we verifies the Hess's law. This illustration of Hess's law. Hess's law can be illustrated by considering the formation of carbon dioxide from carbon and oxygen. The chemical reaction involving the formation of carbon dioxide can be carried out in the following two ways. We know that we can prepare carbon dioxide by giving oxygen, excess of oxygen, and carbon combines with oxygen and form carbon dioxide. That means we can prepare carbon dioxide by one step. Only thing is that we are providing excess of oxygen. Therefore, path 1. Carbon combines with excess of oxygen and form carbon dioxide. The delta H found to be minus 394.0 Kelvin. Kilojoules. Now, path 2. The same carbon dioxide we can prepare by means of two different steps. That is 1. Carbon combines with the limited supply of oxygen and gets carbon monoxide. Delta H for that is minus 110.5 degree kilojoules. Second step, this carbon monoxide combines with oxygen and form carbon dioxide. Delta H for the second step, delta H2 is equal to minus 283.5 kilojoules. According to Hess's law, delta H, that is in the first step, that means path 1 should be equal to the two steps, the sum of the two steps, that delta H of the two steps, that is delta H1 plus delta H2. On adding these two, delta H1 is minus 110.5 and delta H is equal to minus 283.5, you will get the same value as the delta H in one step. From the above, it is clear that delta H, whatever be that in one step, or it is conducted in two steps, that is delta H1 and delta H2, both are same, verifying the Hess's law. Now, based on this, we can do a problem. That is, an assignment is given here. Calculate the heat of formation of glucose from the following data. Three equations are given. One is carbon combines with oxygen and form carbon dioxide. Delta H is given. Two, hydrogen combines with oxygen and form water. Delta H is given. Three, glucose burns in oxygen or combines with oxygen and form carbon dioxide and water. Third equation. But in this question, nothing is mentioned about the heat of formation of glucose. That means how glucose is formed is not mentioned. In how that you have to find out an equation for the formation of glucose, what all elements are required. From the definition, we know that the heat of formation of an compound from its element you should know. Therefore, write the equation carbon, hydrogen, oxygen combines together, we get glucose, and balance the equation. This will not be given for your examination. Since you are doing the first time, the application level question I am explaining, follow that method and try to do it. This equation, once you balanced, that means that equation consists of certain amount of delta H is required for this heat of formation. That is the question. You should find out the delta H for this equation. For that, these three equations will help you. That means these equations can be multiplied with a certain number and two equations can be added or one equation can be subtracted. Therefore, multiplication, addition, subtraction of these three equations will definitely give you this equation. If the right hand side and left hand side and the right hand side till it becomes you get this equation, you should multiply, add and subtract. One thing to remember is that whenever you are multiplying any equation, you should multiply the delta H also. Then only the multiplication is complete. If you are going to multiply carbon plus oxygen giving carbon dioxide with a number 6, you should multiply the delta H also with 6. These are the basic principles to be followed in order to solve this problem. Try to do it, see the answer, and after that only you refer the textbook and see the answer whether it is correct.